Hello everyone. In this video we're going to be going through LeetCode problem 144, which is binary tree preorder traversal. So given the root of a binary tree, return the preorder traversal of its nodes' values. So a preorder traversal, if you remember, starts at the root and then works its way down the tree left to right. So because in example 1 here, then the root node is 1, then you have a null for left, and then 2 for the right branch, and then 3. So the output is just 1, 2, 3. You don't include the nulls. In example 2, nothing returns nothing, or an empty array. The root is just 1 node, so we're just going to return that 1 node. Example 4, 1, 2 returns 1, 2. And the same with example 5. We ignore the left because there isn't a left and output 1, 2. And the follow-up question LeetCode always throws at us is recursive solution is trivial. So they want us to not use recursion, which is usually how you do all these binary tree problems. But we will attempt to do it without recursion. So we're going to pass in the tree node, and we're going to return a list of integers. So the first thing we need to do is create a linked list tree node. We're going to call it stack and instantiate it. So we need to capture the root, or capture these values as tree nodes, and then we need to output them as integers. So we'll create another linked list integer called output and instantiate that as well. So if the root is null, we're just going to return the output, which will also be null at this point. So the first thing we're going to do is add the root to the stack. A preorder traversal uses the root as the initial or the first value, so we're going to add that value immediately to the stack. And then while the stack is not empty, luckily it's not empty because we just added something to it. We're going to take the tree node here, create a new tree node and do this stack poll last, which this drives me nuts. Like poll, it's not even spelled right. I tried to look it up and it didn't really tell me why they spelled it like that. But anyway, I digress. This is going to pull the last value off the stack, which right now we're only going to have the root value in there. So it pulls this off, and then we're going to add that node to the output, which is our list of integers. And then, if the node right is not equal to null, then we're going to add the node right. And then if the node left is not equal to null, we're going to add the node left. And the reason we do it in this order is because we're going through a while loop here, and the pull last is always going to pull the last value, and we always want the left to be taken out before the right. So we put the right in first and then put the left in, if there is one, last, so that it pulls that out first. And then we just return the output after this is all done. Okay, let's try to debug this now. Alright, so I used, let's see, the first example here, the 1, 2, 3. Okay, so we create the linked list tree node stack and output. The root is null, which it isn't. So we're going to add the root. So we add the value 1 immediately. Well, stack is not empty. We're going to create the tree node here, and then we're going to add that to the output. So the output now has the value 1 in there. If node right is not equal to null, that is true. Node left, that's false. Okay, so now we go back to the stack, and we're going to pull the last, which will be the 2, and then we're going to add that, the 2 value, we're going to add that to the output. So now the output should contain the 1 and the 2. Node right is not equal null, that's false, but there is a node left on the right branch. So we'll add that to the stack, we're going to pull it out, and then add it to the output. So the output should now be the 1, 2, 3. And now the stack is empty because when we do the pull last, it actually pulls it out of the stack. So that the stack becomes empty, and we return the output, which is 1, 2, 3, which is what we are expecting. Oops. 1, 2, 3. All right, let's run this through LeetCode here. Successful, and submit it. Ooh, faster than 16%. Let's try that again. Ooh, there we go. 100% that time. Less than 9%. Still uses some memory, but hey, at least we didn't do it recursively. All right, so the last thing we'll do is go through the space and time complexity. So time complexity in this case is O of n. As we add more nodes to the tree, it's going to take longer to loop through all of those nodes. And then O of n for the space complexity too. As we increase n, we increase the amount of space needed. And that is it. So once again, thank you for watching. Let me know if you have questions, and we'll see you next time.